Is that time? Still a straggler coming in.
Down. Shall I shut the doors for one of them?
Yeah, we probably should. Yeah. I'll wait till you do that. Hi guys online. I'm Chris.
Hi, Chris. How are you?
Good. How are you?
I'm really good. Looking forward to this.
Okay. So we're shutting the doors. We're about to get started. There's plenty of water in the back if you're getting sleepy after lunch. Thank you, Emma. Hi, folks. My name is Chris Stoner. I'm the Open Environmental and Geospatial Data Lead on AWS, Amazon Web Services, on the Open Data team. And I spoke with my colleague Emma Pittock from ECMWF about gathering some folks together that aren't from North America, because we seem to be highly North America focused at ECIP. And I thought it might be great to get some folks from Europe over here to tell us a little bit about their perspective. Since Emma and I have been working together for a while, I thought it would be really great to talk with ECMWF especially. If you're not familiar with their data, they're going to go over all of that, as well as their sort of their open data journey. So with that, I'll hand it over to Emma.
Okay, good afternoon. Very nice to meet you all. Thank you for having me here for this. This is entirely new for us. We only learned about this early in the year, so it's a pleasure to present to a different audience. We have three presentations this afternoon that are going to talk through actually the history of trust and collaboration in NWP, numerical weather prediction and climate science. And one of the aspects that I really like about the theme of this conference is that trust in weather and climate they just go hand in hand. Every day when you get dressed in, or you look at the forecast and you decide what to wear, when you decide to go hiking, you trust the forecast is correct before you go hiking. So they're synonymous. So we're going to talk about the history, as I've mentioned, and this is how does trust work in the weather and climate domain? And in particular, the presentation by Umberto is about the history of ECMWF and how it came about. And as he'll tell you, this came about on the basis of trust and collaboration. How can collaboration improve weather and climate knowledge? So we'll talk a bit about how we've advanced over time due to these aspects. And then with increasing amounts of open data, data variety, more data users, how do we ensure trust and collaboration remain? And this is particularly relevant with new machine learning and AI forecasts. To set a bit of context, the trust and collaboration aspect is quite important because without it and without these forecasts, this value could be a lot higher. So from NOAA's statistics, they estimate that it's about 2.6 trillion US dollars, and that's the total approximate cost of damages from weather and climate disasters in the US. And that is the US alone from 1980 to 2003. If you expand that globally, that's an even bigger figure and highlights all the more the importance of working together to keep this number as low as possible within reason. So as part of this, and to get some feedback and some information from the participants, I have posed three questions, or we've posed three questions that we would like your answers to. There is a Slido and there's a link at the end of this. So the first question is, what factors do you consider most important for trusting a weather forecast? And when you go to the Slido, you'll see that it's multiple choice, or you can enter your own answer. The next question is, with the increasing volume of open data, what should be the primary strategy to ensure continued trust and collaboration in this domain? So what do you think we need to continue this, what we've successfully managed for hundreds of years now? And then the final question, and you can use a QR code to access this. We'll show it at multiple points, but maybe think about it during the whole session. Don't have to answer it straight away. Is what role do you think machine learning will play in the future of weather and climate science, especially in relation to trust and collaboration? So if anyone's QR code doesn't work, there is a link. This will be shown at the end of each presentation, so you don't have to answer. That's fine. And so we'll move on to the first presentation. So Umberto, if you want to share your screen. And while Umberto shares his screen, I cannot hear the presentation, although the test worked. Is that because I'm
I-
too short for the microphone?
No, Emma, I can hear you online from the UK. I don't know whether it's in the room that it's difficult to hear you.
Okay, Umberto, thanks. Your screen is there if you put it in full screen.
Can you hear? Can you see my screen?
Yes, it's fine.
Okay.
So Umberto is the Deputy Director for Forecasts and Services Department, and he's probably the most perfect person to talk about the history of ECMWF because he's been there for a very long time and is involved through different roles focusing on users. So Umberto, after you.
Okay. I'll try to do my best. I'm not so sure if the most perfect one, but at least I have been there for quite a while. So yes, I'm Umberto Modigliani. I'm now the Deputy Director of the Forecast and Service Department at ECMWF. I started working at ECMWF in 1996 in user support, and then I became the head of the section of user support for quite a long while. Over the years, then the responsibility of the section moved also to a question of the data provision, not just the use of the services that we were supporting, like the use of the supercomputer. And so I got involved as well in actually providing open data. And now I'm the Deputy Director of Forecast. So I'll try to give you a bit of an overview of how ECMWF started. And one aspect I think that is quite important, if you don't know really the history of ECMWF, is that it was the late 60s, 1960s, when a number of countries in Europe thought that it was important to improve the forecasts that were available at the time. Which were useful, but only in the relatively short range, and to concentrate on see if one could have better forecast in the medium range, so over, let's say, 3 days onwards, and then longer ranges over time. And clearly this was considered something that was not possible at the time to be done by one country alone, and they decided to join effort and create this organization. So in a way, the first step that they did was to put a lot of trust in a new organization, which was created. So I'll try to cover a number of aspects, going through the what is ECMWF and the early part of the history of ECMWF, and then a more, let's say, mature phase, and thinking about a bit the future and what we have learned in all these years. As Emma mentioned, clearly the importance of the weather and climate science and the provision of services cannot be in general understated. It's not just a question of economic damages. The damages are also, as we know, both in the US, but worldwide, especially in terms of life to lots of people. And so public safety has always been one of the most important aspects for all the national met services in the various countries. And clearly improving the forecast has always been at the forefront of the attention. Over time, the weather forecast information has been used more and more by industries, and there are plenty of examples of that. So the usefulness of this data has grown, and clearly is creating a lot of economic benefit apart from reducing damages. And one, I think, of the characteristic really of working in this area is that there is a lot of collaboration worldwide. So not just in Europe, but under the umbrella of the World Meteorological Organization, many of the Met services and other organizations as well collaborate quite closely with the goal in general of increasing the forecast, the quality, and then the knowledge, the scientific knowledge that is associated. It's quite important to highlight that, I mean, all that we are doing really is to provide, in the end, information to allow better decision making and to have this decision making based on scientific type of information. So, but what is ECMWF? And I think here you can see one of our current, let's say, motto, if you want, that where we highlight really the importance of having a common goal. So ECMWF, if it is not so maybe well known in the US, is an intergovernmental organization. So one should understand that ECMWF is not the same as the European Union, is an independent intergovernmental organization with a number of member states. When it started, it had 18 member states, and now we have 23 plus 12 cooperating states, mostly in Europe. So that's where, say, the European names come from. ECMWF, that for many of us sometimes is difficult to pronounce, stands for European Center for Medium Range Weather Forecast. So medium range was one of the important aspects, as I mentioned at the beginning, and it is clearly in the name of the organization. And that is the main purpose of the center, to complement what is being done by the National Met Services in Europe, which at least many of them tend to concentrate more on the shorter range, but there are other examples like the UK Met Office and the German Weather Service and the French Weather Service that also provide global weather forecasting and also a bit longer range forecast and other activities. It's a relatively small organization. It has grown over the years. So currently we have 500 staff. We provide an operational service. So our main purpose is to provide 24/7 operational weather forecast, but we also develop these weather forecasts. So we develop these models. And then, so we have a research department that does this type of work. And we are also quite well known at the moment for the reanalysis sort of product that we produce, the latest of which is called ERA5. In the US, what our model tend to be known as the Euro model. This is the name that you give to our model. Officially, this is actually called the IFS model. IFS stands for Integrated Forecasting Model. Historically, it's important maybe to know that when the ECMWF was established, of course, there was nothing. So we had to build everything from scratch, including getting a building, getting the staff. And at the beginning of the organization, we clearly relied a lot on what was being done in the US. And in particular, we used as a start model that was used by the GFDL laboratory in the US and other organizations. So many of the initial staff at ECMWF actually studied in the US. So again, since then, there has always been quite a strong collaboration with the US. So the early days of ECMWF, and for me, the early days tend to coincide up to something like the early 90s or so. And I didn't, this is when I was not there, so I can only see what has happened afterwards, but this was pre-internet era. So when we started providing this medium range weather forecast, and our first forecast was in August 79, these were sent to our member state via fax. So this is how things were working at the time. And this one of the challenges, let's say, of the organization has always been to handle the information that we were producing and making that available to our Met Service using the technology that was available at the time. And as you all know, things have been developing quite a lot over the years. So since that time, we have produced forecast every day continuously. We tend to be quite proud of the fact that we always have delivered the forecast that we have been producing, even if sometimes there have been some technical issues and some delays, but the forecasts have always been produced. So what were the main challenges, let's say, in the early days? So the main challenges from my point of view, I think, were really that there was a completely new organization that had to be established, and with all the difficulties that you can have, both technically, administrative, and the fact that in the end you have to create something that works both internally in the organization itself and also with all our partners, which are the member of the organization, and in particular the National Med Services of these countries. Then clearly we were producing new products, so this medium-range weather forecast, they were not really available at the time in general in Europe. So this is something that had to be also adopted. And there were, as I mentioned, quite some technical constraints in making available these products, and also in establishing a better collaboration with our partners. The only way really to have this collaboration was to have people visiting in person, if you want, the headquarters of ECMWF that, by the way, are in the UK, in Reading, close to London. So lesson learned, I think, very important, and I will highlight that also afterwards, that is very important to listen actively and to interact with everyone, and in particular with, let's say, the main partner and users of our product and services, that it's important to respond to requirements that have been changing over time, and therefore also to adapt. And for our organization, being an intergovernmental organization with many countries involved, it's quite important to take into account the multicultural aspect and the multi-language challenges, both of the partners that we work with, but also of the staff that work with for our organization, which tend to be from many of these countries. So we tend to have a multicultural environment, which has some potential challenges. So that's the early days. So maturity phase, many things have happened over time. Clearly, we establish the model, our own model, which now, as I said, is called IFS. This IFS was developed as a collaboration that still exists with one of our members in particular, the French Met Service. So it's a joint project and has been joint since the early ages of that. This was in the late 80s. And this model in particular became operational in the early 90s. And then, initially we were producing just deterministic weather forecast. Then for ECMWF, it has always been important to have probabilistic forecast since now more than 30 years. So we have been running an ensemble system. And we are quite, I think, known for a quite specific data assimilation system that we are using until still now, that is called the 4D data assimilation system. But I don't really want to cover too much on our products, but more on the aspect of trust and collaboration. And what I think has become more and more important in this phase of becoming a more mature organization was to develop even further the collaboration with our partners and more widely. So not only we run a global model, but we also try to have a global model of collaboration. As I say, clearly our most important partners are from our member and cooperating state, and in particular the National Med Services and other organizations in those countries. But we have also very established long-term relationship with a a number of other organizations, both at the level of the World Meteorological Organization that is coordinating a lot of these activities, but also with a specialized international organization in the area that is relevant to ECMWF, which over the years has become more and more the use of, for example, satellite data, which is provided to us both from also the US via NOAA, but in Europe via EUMETSAT, and then in terms of development of these satellite instruments, we have a strong relationship with the European Satellite Agency, ESA. We also have other kind of collaborations with other similar agencies in Japan, for example. To continue to have really this kind of development that we have been having, which led to ECMWF being the ECMWF weather forecast as being considered the best medium-range weather forecast currently available. We also clearly collaborated with a lot of research institutes worldwide. And in general, in order to satisfy the needs of our users, as you can imagine, we have a strong relationship with our users in terms of getting feedback on the use of the data and how those should be developed, but also in terms of what sort of products should be made available. So very briefly, I want to highlight a couple of collaboration case studies over the life of ECMWF that is now close to 50 years. So there have been many. But one specific that I wanted to mention is a project that was established by our member state, which was creating a multi-model ensemble prediction as a limited area model in Europe. This was a collaboration of a number of Met services, and this was implemented by them collaborating with ECMWF, but also collaborating between themselves, using the services that ECMWF provide, and in particular the possibility for them to run what we call a time-critical application using our supercomputer, and has been running at ECMWF for a number of years up to 2019. And this was established also as really a partnership between the two, ECMWF and multiple organizations, because this was a jointly supported type of application. Another example, more recent, of collaboration that was for the fact that one of our national Met services was hit by quite a strong earthquake in 2020. That was at the beginning of the COVID time. So they, in addition to COVID, they also got an earthquake that partly, strongly damaged their headquarters. Didn't destroy the building, but really made it quite damaged. And at that point, there was the need to set up a potential backup for their own systems, which we did together with them, and also together with EUMETSAT, using services that we were developing at that time, which we called the European Weather Cloud, but also services like our supercomputer, where they were running their own limited area model. So that was a moment of where in a few days we had to work together for again a common goal in the end of helping a national Met service to continue with their own duties. Moving to the future, again, as a small example of another collaboration that we are just starting. Clearly, we are all probably aware that machine learning is is creating quite some possibilities to review how we do also weather forecast. And at ECMWF, we started a project last year together with our member state to develop a so-called data-driven forecast model, both as a deterministic type of application, but also as an ensemble application. And this is something that now we are working together, especially for some of the aspects that are mentioned in the slide. And generally, okay, we started as well to provide machine learning based weather forecast, which you can access using the QR code if you are not already aware. So what have we learned now with almost 50 years of our life? For me, I think the important aspect is really that yes, ECMWF products are good. They're considered maybe the best still in terms of medium range weather forecast, but I think the quality of the product and the service is not enough, really. I think in order to have a very productive relationship with our partner, it's important to build and continuously nourish this relationship. And to do that, I think for me, it's very important that we continue to listen, that we learn, we adapt, and we continue to serve. And to do this, I think it's important that an organization like ECMWF and similar ones allocate adequate resources to foster this collaboration and trust. Without those resources, it's very difficult to maintain this type of collaboration. And with that, I think, thank you for your attention. And if you have any question, happy to answer.
Okay. I don't know if you can hear that, but they're clapping. Okay, so again, a reminder to have a look at the questions, think about those, because we will discuss them at the end after I've done a very short presentation. Is there any quick question for Umberto? And if we can also have questions at the end in the context of the other presentations if you prefer. Dave, go for it. Oh, yes, it's not on. Okay, there's one question coming, Umberto, but I think I have to repeat it here. Is that right?
You should be able to hear. Hi, this is Dave Jones with Storm Center Communications. I just had a quick question on your last slide. It was a great presentation. What would you consider adequate resources for collaboration?
Well,
Wow.
that's not easy, but I think it's good that you have a certain number of people. Here I'm talking about really people that have time to invest, let's say, into maintaining this kind of relationship in getting the information, in making sure that if you listen to whatever your partner is saying that you should be doing, something is actually happening. So for an organization like us, that where at the moment it's about 500 people, still we have teams that take care of the support of these users, let's say, teams that take care of the engagement with the users of our products. And this is more like the day-to-day type of activity. And then, of course, there is at the level of the management, we have a various type of interaction with let's say specific contact points in the various partners. So it's people, but it's also processes.
Okay, thank you. Okay, we are slightly behind time, so I will thank you, Umberto, and move on to Simon now. Simon, can you just
stop sharing? Yeah.
And can you share, Simon? There, perfect. Okay, and Simon.
Can you see my screen?
Yes, we can see it and we can hear you. Thank you.
Perfect. Thank you. Thanks, Emma, and good evening, or sorry, rather good afternoon, everyone. It's a real pleasure to be joining you today. My name is Simon McClellan, and I'm head of data at the Met Office here in the UK, where I'm responsible for managing our vast volumes of weather and climate data, and also working to maximize their value and impact for our users and our collaborators, ECMWF being one of those very important collaborators to us. As I'm sure you know, the weather and climate isn't constrained by borders and boundaries. It really does have freedom of movement. To predict the weather here, there, wherever, here in the UK, for example, it's essential to understand the current state of the weather further afield, what's coming our way. And that is often beyond our shores and borders. And the image on your screen now shows a lot of our weather comes across from the Atlantic, and not many people live in the Atlantic, so that's a particularly challenging thing for us to do in Europe. But I'm going to take you back further than Umberto's presentation, back beyond fax machines. And I've worked for the Met Office slightly longer than Umberto's worked for ECMWF. I've worked for the Met Office coming up 35 years, but I'm going to take you back even further than that. I'm going to take you back perhaps 8 years to before fax machines, when trust in the very smallest amount of data changed the course of history. But first, I've just got a couple of slides to give you a bit of an introduction to the Met Office. Let's see if my slides progress. So we've been around for maybe 160 years. And over that time, we've proved ourselves, certainly in the UK, to be a major national asset and part of the UK's critical national infrastructure. As it says at the bottom there, our stated purpose is to help you make better decisions to stay safe and thrive. And our data is right at the heart of that. So across the world, around the clock, every single day, people are making decisions based on the weather. Individual decisions that Emma talked about earlier on, about going hiking or whether to pack a brolly, business decisions, policy decisions, immediate and long-term decisions. At the Met Office, we provide weather and climate services based on world-leading science. And provide impact-based warnings and advice to a variety of customers, both internationally and at home in the UK, from surface and air transport, emergency responders, defence, industry, national infrastructure, and governments, and of course, the general public. Behind all of that, though, behind all of the icons and images on the screen, we are a big data operating, a big data organization operating in the global information economy. So we recognize our weather and climate data as a key strategic asset at the Met Office, at the heart of our purpose, as I said again, helping you make better decisions to stay safe and thrive. Because we only make an impact when our data, our products, our services, our advice get into the hands of those who use them to shape their lives and the lives of those around them. And as I said, this includes the public, governments, private sector, academia, both here in the UK and around the world. We predict the weather for today, tomorrow, next week, and next season, whilst looking further ahead at how climate may change over the coming decades. Here are just in the boxes, here are just some of the use cases and benefits derived from our data over those different lead times. And the important thing here being the inherent uncertainty associated with them. And that is the key point here, understanding the uncertainty as part of the trust conversation. How do we trust the data, given that often it's some prediction into the future? And some people say data equals fact. That's not necessarily always true in our case. When we talk about data, it's about describing the future scenarios. It's as much about describing those future scenarios as it is about measurements and records of the current or past conditions. When we talk about data, much of it can't really be described as fact. Those predictions of the future haven't happened yet, and we keep updating them with increasing accuracy and with increasing confidence the closer to the event that we get. We're seeing this lack of distinction as a growing problem, but data consumers need to be aware of that inherent uncertainty in the data as they use it and when they need to use it in their decision making. So if you've got an outdoor event on Saturday afternoon and you want to know if it's likely to be wet at maybe 2 p.m, I'd say the forecast on Saturday morning would be the most accurate, but that might be too late for you to change your plans. So you might need to make a planning or logistics decision maybe on Thursday evening. Okay, well, that's the time that you need the latest forecast. That's the time when you're going to make a decision based on our best estimate of the weather for that particular period on Saturday. But you're doing that knowing the associated uncertainty, the confidence that we might have in that forecast, and the likelihood that that prediction will happen, the confidence in that data. It's the best we have at the time you need to make that decision. So hold that thought as we go back 80 years before supercomputers and satellites to arguably the most important forecast the Met Office has ever made. It's June 1944, at the height of World War II and the Allied invasion of northern France, or Operation Overlord, or D-Day as we probably more familiarly know it, had been planned for the 5th of June. The only thing that the Supreme Allied Commander, General Dwight Eisenhower, and the Joint Chiefs didn't have control over was the weather. And that year, early June 1944, was particularly unsettled. Basically, the Allied commanders had this list of wish lists for conditions for an invasion. So they had to have quiet weather for 48 hours before D-Day to allow the convoys of ships and craft to sail from their various base harbours and form up on the south coast of England. And then they needed 3 subsequent days of winds of less than force 4. They also needed less than 30% cloud cover below 8,000 feet, with a minimum cloud base no lower than 2,500 feet to allow the planes that were carrying parachutists and tugging gliders to deploy. And they needed visibility more than 3 miles. Oh, they also needed low tide at dawn on D-Day itself. Oh, and on top of that, darkness when the airborne troops went in, but moonlight once they were on the ground. So between 1 day before and 4 days after a full moon. From the outset, the odds of even broadly acceptable weather were maybe 13 to 1, and these roughly trebled as soon as the requirements for the full moon was added to the equation. It fell to a team of forecasters led by Chief Meteorological Officer at the Supreme Headquarters of the Allied Expeditionary Force, I had to write that bit down, a certain Group Captain James Stagg from the Met Office, to provide a 4 to 5 day forecast. Although this was nearly impossible in 1944 with very limited observations and long before the advent of supercomputers and satellites, 1 or 2 day forecasts were more achievable. As I mentioned, having a good understanding of the current conditions beyond our borders is vital in predicting what's coming our way. And in Northwest Europe, as I said, that often means out into the North Atlantic. In those days, these precious few observations came from weather ships and dedicated aircraft flying missions out into the Atlantic, taking weather measurements by hand. Bottom left there, you'll see Jean Farron from the Women's Royal Naval Service, who was part of Stagg's team, relying on and relaying those vital weather measurements that helped influence the decisions of the D-Day commanders to delay the operation. She wrote, "You had to be quick. That was the main thing. Get it off the teleprinter and onto the chart so that they could quickly assess the forecast and go to Eisenhower so he could make some decisions." It was in the map room there in the centre at Southwark House on the south coast of England near Portsmouth that Stagg briefed Eisenhower and the Joint Chiefs on the weather for the D-Day period and where the final decision on when to launch Operation Overlord was taken. Based on their very limited observations gathered out in the Atlantic, it became clear during the 3rd of June that a low pressure system and associated fronts would sweep over the UK on the planned date of the 5th of June. Not everybody agreed, but Stagg trusted the data and the expertise of his team and decided to advise Eisenhower that conditions would not be suitable for the 5th, and the invasion was postponed. Their forecast proved correct, but the pressure was now on, excuse the pun, to find a new weather window with more favorable conditions for the invasion. But no one could agree on whether the 6th would be any better. Then, on the 4th of June, these vital observations started to indicate that there might be a temporary fair weather interval on the 6th. No one was sure if it would be good enough or how long it would last. And Stagg's diaries from the time show the incredible stress he was under. He wrote, "I'm getting rather stunned. It's all a nightmare. Imagine the sense of responsibility given a forecast that sent thousands into battle. His advice would decide the future of over 150,000 men and women of the Allied armed forces and could directly impact the outcome of the entire invasion." On your screens now, you'll see the Met Office chart for 1 o'clock in the morning on the 5th of June, showing low pressure and a cold front lying across the English Channel. but also indicating high pressure building out to the west. At 3 o'clock in the morning on the 5th, at the commanders' conference, STAG took the momentous decision to advise that conditions should be favourable for a landing on the 6th, and General Eisenhower made the final and irrevocable decision to go ahead. The rest, as they say, is history. Comparison of this Allied weather chart with a German chart shows that the Allies had access to observations out into the Atlantic that the Germans had no way of accessing. So their forecasters would have been unable to even predict the weather window on the 6th. Trusting in these small but significant data points and trusting in the expertise and advice of those interpreting them gave the Allies a significant tactical advantage in decision making and brought valuable time to securing the Normandy bridgehead. On your screens now, I've just flipped over. It looks the same. It's another chart of the same from the same time. But this is the chart on the 6th of June, showing the increased number of observations available across to the Allied forecasters from occupied Europe out there over Germany into the east of France, because the Allies had broken the Enigma code and were able to decipher on occasions weather observations coming in from across Europe. But it also shows the forecast ridge of high pressure sitting a bit further west of the UK than expected, which led to more marginal conditions than originally predicted. But the predicted weather window proved just about to be correct. By 1 o'clock in the afternoon, seaborne troops had been landing for 7 to 8 hours. So despite working with limited data in a period of very unsettled weather, and without the sophisticated technologies and models we have today, STAG and the D-Day meteorologists had made arguably the most important forecast in history. And if you look closely, I don't know how big it is on the screen, just in northern France, there's an observation near Caen. And this is the first weather observation taken by the Allied troops following that invasion. So out there, meteorologists, people taking measurements within hours of landing on the beaches. So what would have happened if the window had been missed? Well, 2 weeks later, in a secret memo accompanying the official report to Eisenhower, STAG noted that had D-Day been delayed until the next suitable tides, and the only realistic other option available to them, the troops would have run into the worst weather in the English Channel for 20 years, and the invasion would have been a total disaster. Oh, sorry. Where are we? At the top of this memo, you can see Eisenhower's handwritten note to STAG. It says, "STAG, thanks, and thanks for the gods of war. We went when we did." So I think pretty much this is the most important forecast that the Met Office has produced. And it was based on trusted meteorological expertise alongside trusted but very limited data to delay D-Day by 24 hours. It serves as an 80-year-old lesson that data-driven decisions depend on that vital combination of data and the expertise in how to use it. Now, back to the present day. And you won't be surprised to learn that these days our data is huge. Global observations, computer-generated weather and climate predictions, various resolutions across the globe and at various altitudes through the depth of the atmosphere. And of course, the weather's constantly changing, so our weather really is dynamic. This global interaction and movement of weather drives a need for global interaction and movement of weather data. And this 24/7 international exchange of accurate and trusted data is something that the global Met community has been incredibly successful at for many decades through the World Meteorological Organization, as Umberto referred to as well. So day in, day out, this heritage has enabled us to share safety-critical data and products in support of operational weather forecasting and forms the foundation of our ability to provide weather services that are based on the best available information. Extending beyond the established WMO domains of weather, water, and climate, the new updated WMO Unified Data Policy, there on the left of the screen, now encompasses 7 domains of the Earth system. And that includes oceans, cryosphere, atmospheric composition, and looking at space weather as well. This intergovernmental agreement allows all member states to share trusted data with each other on a free and unrestricted basis. These data policies and licenses define how data can be used, by whom, and under what conditions. The technical standards govern how we encode our data for sharing between systems. But things are changing. We estimate that our systems process something close to a petabyte of data every day. It's becoming unrealistic, unaffordable, and soon it won't even be possible to distribute our highest resolution data within a useful time frame in the ways that we've been doing so up until this point. So how do we do that? Well, I'm hoping, looking at the time, I'm hoping that Jeremy's going to pick up that story shortly. So what are my takeaway messages from today? There you go. Data-driven decisions need a combination of data and the expertise in how to use it. Having trust in data needs an understanding of how and when to use it, and how and when perhaps not to use it. So I think that might be my last slide. I don't know, Emma, how we're doing for time, but there you go. I did as you asked. I've put the QR code on my final slide. Thanks for listening, everyone. And Emma, back to you.
Thank you very much, Simon. That was brilliant. So are there any questions for Simon, very briefly? Again, you can ask him at the end. There's one. Where's the microphone gone? You've got it. Just 1 second, Simon.
Okay.
Oh, and for those who don't know what a brolly is, Simon used a very close spelling.
Sorry.
A brolly is an umbrella. So when
Sorry.
so you know.
I did my best.
Appreciate the dialect linguistic tidbit today. Thank you for that. My question for you, Simon, is I've spent a lot of time beating my head against walls trying to help people understand those last points that you made. They're not always things that people want to hear. What strategies have you found to be most successful in driving home the message that you need expertise as well as just the data, and you need to know what questions can be answered and cannot be answered with data of given characteristics? How have you managed to get that message home to people who don't necessarily want to hear it for whatever reason?
Wow, that's a great question. I think it's an ongoing battle. I think particularly, as I said, these days, technology has allowed more people to be able to access our data, whether it's through cloud technologies. AI will just bring that more and more, bring more and more of a challenge, whereas previously people got a weather forecast because they saw the guy on the TV or the woman on the TV presenting the story. These days, by having access purely to the data, I think that's a big challenge. So for years through the WMO community, we've been great at sharing data with other Met services, other like-minded organizations that understand that cone of uncertainty that I showed. And as experts in meteorology, we understand that uncertainty. But I think one of the challenges that we at the Met Office and perhaps the wider Met community have is, whilst we can make our data accessible to other people to use, actually getting it in a way that is understandable. And I think understanding and accessibility to data is a really important thing so that people understand it. But I think that the really important thing is, you could do something absolutely crazy with the data, but there's no one to tell you that that's not that is a crazy thing to do with it. And so I think it's a real challenge. I think it's something that I'm starting to see more and more as more and more people want to use our data but don't have a PhD in meteorology. And why would they need to? But our duty is to help them understand how to do that. So I think whilst technology is a key thing for us to focus on, I think the human accessibility and understanding of data is as big a part as allowing our technologies to be interoperable and accessible. So I don't think I necessarily have a question, but I certainly agree that it's a big challenge. Perhaps one we can discuss later.
Say that again, Simon.
Perhaps that's one we can discuss later.
Right. Thanks. Okay, thank you very much, Simon. So we've talked a lot about the history and how trust has been absolutely crucial up till now. And now Jeremy is going to cover some of the future in data sharing, and then I'm going to cover a little bit more of the future. And hopefully at the end we'll have a discussion around the history and the future of this. So I think, Simon, that is a very cute dog, but I may need you to stop sharing. How do I share the screen? This one. No, where did it go? Very odd. Okay, very good. Go for it.
Okay, so I'm Jeremy Tandy. I'm from the Met Office in the UK, which is the government agency for weather and climate. I also wear other hats as well, on this occasion with the WMO. Just in case you don't know, the WMO is the World Meteorological Organization, and that's the UN, the part of the United Nations that has a mandate for weather, water, and climate. And included in that mandate is the international exchange of Earth system data, as Simon was mentioning earlier. And this thing that I call WIS2, the WMO information system, second generation, is a continued evolution of that change. And just for fun, the formatting's gone a bit odd, but hey, you can still see the QR code. So, so Rocket, answer the questions, there will be no excuses. So let me just start that we say that WMO, the WIS2 is the data sharing framework for the 21st century.
Is that,
Well,
there's some green box around it. I don't know why.
and that could be because there's a dialog box open. Like, yeah. Dang, let's get rid of that one. No.
Okay. Sorry about that.
That's okay. So history, because this slide was about history. So let's take it to 1860. Back then, the telegraph was the first thing that enabled people to collect information, weather observations from a large geographic area, and that's when weather forecasting really kicked off. And then in the 20s, people connected typewriters to telephone lines, and that's where we got teletypes. And then a lot of you may know this thing called the global telecommunication system. So pre-internet, we had this store and forward mechanism of pushing data around in a closed system, and that has been the mainstay of real-time weather data sharing. So Bob, you live and breathe it, I know.
That's what it is.
I
Sorry.
Here is, and then swap.
But it's okay up there.
But that's not, maybe just duplicate slideshow.
Okay.
Yeah. I think, wait, let's try and make sure.
Thank you very much, Jeremy.
Yeah.
it's my pleasure to keep you entertained. Okay, all going? Right. Okay, so, and then in 2007, we thought, hey, you know, what we need to do is make this information more available, more discoverable, so we invented catalogs. We used ISO 19115, which many people will hate because it was too complicated, so we never quite met the objectives that we had. So WIS 2.0, which is approved at the 19th World Meteorological Congress, is the evolution of that. And it kind of addresses, I'm going to talk quickly because otherwise we're going to run out of time and you all want to go to the reception, right? So the data challenge that we're trying to address is bigger data, more than ever before. And I think we've seen that from many presentations already. We also have increasing demand. People want to use the information for making policy decisions, for making the right decisions, whether to go launch your troops or to hang your washing out, you know, everything in between. We, as a human race, are having to deal with massive challenges around climate change and severe weather. Everybody needs weather data, and everybody should have access to weather and climate data to make those decisions. And then, of course, we have cloud adoption. There's this thing called cloud that makes the whole economics of how we do data different now, right? So what WIS2 is trying to do is build on 3 pillars: simpler data exchange based on open web-based standards and providing cloud-ready solutions. So that's kind of the rub of what I'm going to give to you. WIS2 is a federated system, so we have WIS nodes, and so every country and territory around the world, so that's 193 members of WMO, will have at least one WIS2 node publishing data. So this is a global enterprise, and we have some global services which make the whole thing tick along sweetly. Go on, there we go. Right, okay, so let me give you an idea of where we're at. We've been on this track for a little while. In 2023, we ran a pilot. You can see from the chart here that we have a whole bunch of green dots all over the place. This is just 60 members of WMO, 60 countries sharing surface-based weather observations, just to prove that we could get the global data sharing working, and still, that's quite a lot of coverage on the map. This year, 2024, we're in a pre-operational phase. 2025, we go operational from January. And then the GTS, that lovely thing that you all know, that will be phased out over the next 5 years, but that's okay because you'll be able to get all the GTS information through open, normal, web-based technology easily using Wiz2. Genuinely, it's going to be easy. If you want to know more, there is a little QR code in the corner. That's not for questions. That's actually linking to a video we did for Congress last year, which is an explainer. So it's about 7 minutes long. It's kind of fun. But let's just dive into a particular example. I'm going to pick somebody who's Dutch, and they want to share data from their national network of land-based observing stations. So they go, okay, so I've read the manual, and there's a whole bunch of links up in the top corner, which on at least one version of this slide, it all lines up. It says draft. They are approved. It's just that we're awaiting WMO to publish them officially through their library, so it's easier for me to link to the draft ones. Anyway, they see from the technical regulation that what they've got here is a data set, and they're going to follow the instructions in the Wiz guide, and they're going to establish a Wiz2 node to share that data set, and they're also going to provide discovery metadata. More on that in a moment. The Wiz2 node allows them to publish files. Yes, I know, files, hey, but that's the way that the majority of people in WMO work and will continue to work for the foreseeable. But we also now can introduce interactive APIs. We would prefer open API and self-describing APIs. But the secret sauce is really the Wiz2 notification messages. This is what allows people to see in real time what data is changing, what metadata is new. This is published, it's a simple GeoJSON payload. It's published on MQTT using a standardized topic hierarchy. And this is new. We've never done this before. We're just borrowing patterns that we've seen used in other places. We're not sending the data in the MQTT, or you can if it's small, but mainly it's about saying the data is here. Go fetch it if you want to. And then finally, that discovery metadata is what we call the Wiz Core Metadata Profile version 2, and that extends OGC API records and GeoJSON. It's pretty similar to Stack, but not quite, but it's enough, it's close enough. So this is kind of a dream for me. Somebody comes up to me and says, tell me more about metadata. So I had to say, am I dreaming? Because you've asked. In Wiz2, the discovery metadata has to conform to this Wiz WMO core metadata profile, and it contains the information you need for discovery, and that's it. You can put more in, but we're not asking for more. We're just asking for stuff for discovery. So it's things like identifier, titles, descriptions, and then most importantly, where you can access the data. These are resolvable links. No more, it tells you that the data exists somewhere and somehow you're supposed to know that you're supposed to go to somewhere. Resolvable links, that's really important. So it could be files, it could be APIs. It tells you where to subscribe to notifications too. So where is that MQTT endpoint? And kind of that allows me to see what the data set contains and how I can access it. But it's also worth knowing about the Creative Commons, recommendations for sharing of climate data, really helpful in choosing the licenses which you need to use and what information is needed for people to cite our data when you use it. We talk about trust, right? Trust goes both ways, right? If you're using somebody's data, please cite them. It allows them to prove that they're doing something useful and to carry on investing in that. So data policy, rights, license, citation, these are all really important things to include in your metadata. So my man on the side there says, excellent, the conditions of use and license are clear. How many times have you heard people say that? I don't know. And they can see how to attribute the data as well. So what did you say about global services? My things don't work. Anyway, it doesn't matter. So global services, we have four types of global services. We have the global broker, and that provides highly available global distribution of those notification messages. They say when metadata and data is available for download from Wiz nodes or global caches. We have a global cache. In fact, we have 5 global caches, and they provide highly available HTTP download of core data, which is cached from all those Wiz2 nodes. We have Global Discovery Catalog that provides users with an API to discover data sets using that metadata that we've collected together, and a Global Monitor that reports the health of the whole WIS2 system so that we can make sure that things are working properly. So, global brokers, we have 4 global brokers, and because I can't quite see, can you see? No, you can't see. Can I get rid of the bar on the top? On the green? Just here?
The 3 and hide floating.
Hide floating panel. Thank you. Right, okay. So we have 4 global brokers, and you can subscribe to the notification messages from WIS2 nodes. They all subscribe to those, and then they republish them for forward distribution. The global brokers are designed for high availability. The global brokers also subscribe to each other for resilience, and they discard any duplicate messages that they've been received. Most importantly, fully meshed network is not needed. So some people don't like to talk to some people, and that's the joy of geopolitics. But the system still works, and it's resilient. Then we have 5 global caches, Japan, South Korea, China, Germany, and a collaboration between USA and UK. They subscribe to notification messages from at least 2 global brokers, and again, they discard duplicate messages. And then what they do is on receipt of a message, they download a copy of the data, and then they republish it for access, and then they publish a new notification message that says, you can get the data from me now. And you probably couldn't see, but between Korea and Germany, it's an example where maybe a global cache didn't download or couldn't download the data directly. They receive notification messages from other global caches, and then if they haven't got the data already, they will download it from other global caches. So you can see here we have multi-layered resilience. Bits of these systems can drop out, and it still works because we have 4 or 5 of these things in place. We have 2 global discovery catalogs where we curate that discovery metadata published by WIS2 nodes, allowing users to find the data sets and meet their needs so they can see also how to access and subscribe to notifications. The global discovery catalogs are indexed by search engines. We're using schema.org tags and things like that so that users can discover data sets using their preferred means. We have 2 global monitors that collect metrics from all the global services and publish them as real-time dashboards so that not only we can see it, but you all can see it as well, right? We can indicate the health of the whole WIS2 system. And then alerts are triggered when intervention is required by service operators. So, here we go. So, if I was somebody wanting to use the WIS2 system, I would start by searching for data using my favorite search engine. I would subscribe to notifications from one of the global brokers listed in the metadata that I could see. Based on the notification messages I get from the global breaker, I know where to download the data, in this case from the global cache that's mentioned in the first notification message that I receive. You may get more than 1 notification message. You need to be savvy on that and ditch the ones you've already dealt with. So just a little bit of a deep dive into the US-UK collaboration here. The core data that we're sharing at the moment, it will get more. It's around 82 gigabytes a day, 100,000 data objects, 24-hour retention. It is only a cache. It's just 24 hours worth of data. It's currently pre-operational. And this is a collaboration between the Met Office, NOAA, Synoptic Data, who've done a bunch of the engineering about this. Our friends at AWS has helped us out with some solution architecture and some credits. And of course, we are leveraging the Amazon Sustainability Data Initiative to make sure that the data is available to people on the cloud. So it kind of comes in 2 parts. We have Global Cache Manager, which is infrastructure as code largely. It is fully cloud native. We're deployed using Cloud Developer Kit. We're using Lambda for serverless processing of messages grouped into batches to retrieve the data for caching. We have an event-driven architecture using SQS. We're using Elasticache for managing state. We have a couple of things which aren't Amazon managed services because not everything is, we're not lucky enough for everything. So we're using ECS to manage Paho as an MQTT client, and then Mosquito as an MQTT broker. But the important thing here in terms of the collaboration with ASDI is that we're using the S3 for persistent object storage, where you can come and pick up the data, and ASDI are covering the egress costs, which is super important for organizations like mine, who are funded by government, funded by taxpayers. Because we're working in collaboration with Amazon, you're picking up that cost for us, and Matt, you're over there. Thank you. And also, because we're using cloud, because ASDI comes with CloudFront, it doesn't matter which region you are in the world, ASDI will make sure that the data is replicated to the region where you need it. So, all good, right? Sustainability solutions, global sustainability solutions need data, right? And the data is getting bigger, it's growing. The storage and analytics services provided by AWS can help, and I think this is a perfect example of how the future needs to evolve, which is we have public-private partnership around this WIS2 and ASDI thing. It's a great example of how we can work together on our respective strengths. AWS provide open data sponsorship with credits, and Chris, that's your bag. We have the Amazon Sustainability Data Initiative, and that's Matt's bag over there. Am I right? More or less. We have the AWS Data Exchange as well, which is another mechanism that you can share data. ASDI is basically making access to data faster, cheaper, and easier, and we have just a few organizations which are involved, which are publishing data already. But the key point is that we can work together to solve these problems. It doesn't have to be government over here and commercial vendors over here. Actually, we share the same goal, which is to save our planet. So what's next for big Earth data sharing at WMO? We have a new study group which has been created, which, forgive the spelling, it is called SGFIT, but it means the Study Group on Future Data Infrastructure. Its objective is to assess the practical application of future technology of data exchange for public weather services in the context of ever-increasing data volume and variety. So basically, we create too much data for people to use. So how do we deal with that? There are 3 streams. One is to move where the modeling happens. Basically, if we're using AI models, they're much smaller. You don't need a supercomputer anymore, so you can run them where the data is needed. Otherwise, you can do data proximate compute, so you move the processing to where the data resides at one of these big global centers. And finally, you could just move less data. You could apply smarts, whatever that means, which might be AI-driven compression that says, you know what, in this weather field, much of it is boring. We don't need to send that data. We only need to send where the fronts are. And then at the other end, the AI can fill in the gaps, and it doesn't really matter what it does because it's not interesting. Visualization is another mechanism where we can actually extract the right thing. For low-income countries, visualization is still really, really important for the way that their business processes work. So we're trying to do these things. There will be a virtual workshop on the 23rd to 25th of September. I'd love you to be involved. If this is the kind of thing that you're interested in, please let me know, and I'll be able to send that information. The idea is that we can create that list of what's important for our constituent members and then set it on the work plan for the study group. So that's all I had to say, which is just as well because I need a drink. Thank you very much. I'm happy to answer questions if we have time.
Sure. If there are questions for Jeremy, we can do that.
Thank you.
Very, very good. Well done.
Hey, Jeremy.
Hi.
Ethan here. I guess I'm just curious about latency compared to the GTS, like getting to the global brokers, getting to the global caches, and then getting to users. And I guess that relates to performance and scalability. I mean, there's going to be a huge increase in the number of direct users, I guess.
Yeah.
They'll be making smaller requests, but I guess, yeah, just interested in if you've looked at that, how that.
Okay, so with the GTS, the latency is largely driven on how often the message, the message switches pole. So that means it can take several minutes to get data through the system, sometimes longer in some parts of Africa. In some parts of Africa, the data doesn't arrive at all because the message switch isn't running. What we discovered during the pilot phase and through the pre-operational phase is that the time it takes from the data being published by WIS nodes through to it to being available in the cache and visible to users is seconds. a small number, a handful of seconds. So we're really happy with the speed at which this works. And in terms of scaling to, I mean, Simon talked about the new WMO data policy that reinforces or reaffirms WMO's commitment to free and unrestricted exchange of data. It was so in the GTS, but you had to be on the system. Now we're making it web accessible, and I think that it is several of the global caches are taking on the responsibility to make that data available themselves with on-prem solutions. Personally, I think the cloud is the way to go, so I'm really happy to be partnering with Amazon to make this happen. And that's how we deliver scale. That's how we deliver data at scale.
Very quickly, I'm curious to know what conversations have been had in terms of long-term keeping costs low and long-term keeping data accessible with the private sector partners, you know, terms and conditions long-term, that they don't change.
Okay, so in terms of long-term partnerships, so WMO as the UN organization doesn't have any direct relationship between how NOAA and the Met Office have implemented the global cache. So this is a relationship that we as two governmental organizations have set up with Amazon. We're using the normal ASDI relationship, which I think is a 2-year rolling window. But I think that the way we see it is that the data that we're bringing and making more available continues and will continue to be useful to the community. And so long as that's so, our friends from Amazon will keep serving it for us. This is where I asked Matt and Chris to shut their ears. We also are a multi-cloud organization, and we play a lot with Microsoft. And so it's really important for us that we continue to work with not just one vendor, but multiple vendors. And that way, there's really nothing which is super clever about what we've implemented for the global cache. It could be, with a reasonably straightforward engineering, ported over to Azure or GCP, and we just put it in a different place, right? So, but for the time being, there is no need to do that. But always in the back of my mind is a phrase which somebody said, I can't remember who it is, but never start something until you know how to stop.
Quick question here. So, I mean, this is awesome. My question is about business model and sustainment. Mm-hmm. Who's developing this, and who's making decisions from a sustainment engineering point of view of how, I mean, there's a lot to this, that decisions need to be made day to day, in a potentially unilateral, just get the job done and keep the lights on way. Yeah. But it's also part of the WMO. I'm curious how that works.
Yeah, so the way that WMO works is a little different to the rest of the UN agencies. It's largely the national Met services like NOAA, Met Office, JMA, the Japanese Meteorological Agency. They're the ones who they foot the bill for making this run. Okay, so your government is paying to make this run, but that's because they signed the convention which said we want to be part of WMO. They've agreed at Intergovernmental World Meteorological Congress, that they will do this and they will commit to doing it. Now, there's a whole bunch of governance around that, which I won't bore you with, but it takes a while to get decisions to be done. In terms of engineering and how the standards can evolve, we work very closely with folks who are involved in OGC. So Tom Crowley-Dis, that you know well, is very much involved in that. But we have expert teams. Those expert teams are populated by people that we draw from WMO members. The member is not just the Met Service, it is the country, right? So we can pull in anybody, any specialist expertise. We have an open process. We are transparent in how we do things. I mean, I'm eating all your time, so Dave, we can talk about that afterwards. But there's a whole bunch of governance about making this work, and openness and transparency about driving it forward is super important. And then having governments agree the decisions and then bankroll it.
Hi. Since Dave said this is amazing, I'll be intentionally sort of confrontational. Yeah, so I'm Ken Casey. I work at NOAA at our National Centers for Environmental Information. I'm really curious because, you know, you're really talking about expanding access to the data to a much wider audience. But at the same time, you're talking about minimizing the amount of metadata that's coming along with this stuff. And so I see a potential conflict there. And I'm wondering if you thought about that, earlier in there's an AI session that talked about how much, in order to enable all of the world's great new AI and ML applications, for example, you need more metadata, and yet you're trimming metadata back. I'm just curious how you'd respond to that.
Okay, so my experience is that I have 15 years of pain in dealing with trying to get people to write 19115 metadata. Because it looked big, but actually we were only ever asking people to write a little bit. But because it came in a big package, people felt compelled to write a lot of stuff. So we're asking people to commit to writing a little bit, but there's nothing stopping people adding more data, more metadata. And indeed, if you think about a core and modular approach, I would talk about data provenance as being a complicated subject in its own right. We can put that in the discovery metadata alongside the citation and the description and so on and so forth, but only do it if you're ready, right? The same goes with data quality. Data quality is a really, really complicated thing once you get down into the details. You can put that in here. There's nothing stopping you extending that. I suppose it's a little bit how Stack have got extensions, right? You can extend it, you can add it. Because we're trying to get 193 countries to do it, we have to start with a small amount. Otherwise, people never start. But I am totally receptive to your comment. Okay, thank you.
Thank you. So I am the last speaker. Mine is shorter, I promise. And my presentation is more about the challenges we will face. And I don't necessarily propose solutions to these. It's more for discussion and more about where we're going. Have I done that wrong again online? Can you see? Okay, can someone tell me what you can see online, or if it's...
It's not your full screen.
It's full screen and it's fine.
It's not full screen.
Not.
It says from cloud to future.
Now?
Yeah,
Is that-
that's full screen.
What? Oh. Why is this so hard?
It's good for us.
Let's try it again. This one, right?
Yeah.
No, yeah.
Oh, and it was duplicate that.
And display, duplicate.
Yeah, thank you very much. You think
Right.
I'd learn? Thank you so much. You would not believe that I actually work in user support and I show people how to do this in my day-to-day job, but I don't use Windows, to be fair, so that's my excuse anyway. So my presentation is from cloud to future. So Humberto gave the history, we've talked about the past, we've talked about the progression to WIS2, and so I'm going to talk a little bit about some of the complexity, the challenges that we see and that we face, as well as interlacing it with a bit more about ECMWF's current landscape. It's not moving. Come on. So the topics in this are the new and evolving data sets, and this is not just from ECMWF, this is more wide. We have more ML and AI models, and they are creeping up really, really quickly. We have training data sets, a new concept of these large historic or reforecast data sets. New methods to access data, so we're having to educate users all the time in very fast evolving technologies. But how do we ensure that users trust the actual output of all this? We're making all this work, doing all this effort, but we still need them to trust the end product. We have a lot of data disjointedness, and technology exacerbates this. The faster you move with technology, the easier it is to have some people lagging behind, people getting distracted or going in different directions. So how can it be addressed in the weather and climate data ecosystem, trying to focus on a global collaboration, not just one man for themselves? And then the bigger picture is how do we ensure continued trust and collaboration? And with all of these things, how do we make sure that we sustain this? And we have done for a long time, so I'm sure it's possible. It's just something that we need to keep in mind while we're working towards new technologies, new models, etc. So the current landscape, from an ECMWF point of view, this is going so fast, and I mean really, really fast. We've seen machine learning models coming out. We have 5 in our current open charts products, so that's the image on the right. We published Fushi, GraphCast, Pangu, AIFS Deterministic, now AIFS Ensemble, ForecastNet, so that's 6, sorry. And users can see these. They're open and available, and they can compare, but they don't know necessarily what's behind them. We then have novel data sources. So ECMWF, we receive around 800 million observations a day. And this is growing. We get more from new places. Internet of Things, more satellites are going up, new sensors, crowdsourced observations are coming in. I know that Germany is getting mobile phone observations from people who are taking pictures of the clouds and saying what they think about those clouds. More data sets. Open data is becoming more prevalent. There's a lot more open access science, a lot more open access technology. Modified data sets, a huge thing now is to take data sets and then put them into a new format like ZAR. I know that this is done from ERA 5. It's in ZAR format in the cloud, for example. And with all of this comes more users. And traditionally, from ECMWF's point of view, our users used to be quite meteorologically savvy. So they knew what they were doing. They usually had degrees in meteorology or some formal training. Now we see users from every domain, and they don't necessarily have training. They have different types of training. They have experience in economics. They have experience in the insurance industry. But they're all accessing the same data set via the same technical means with different skill sets and different backgrounds. And serving these different user types is really quite a challenge, and making sure that it's reasonable for everything. So these are the kind of the landscape of things, if you like. And I've just tried to summarize the challenges for this. So data accessibility is a theme for one of them, is the complexity of accessing and interpreting vast amounts of data. I said before that I work in user support, and I deal with about 6,000 JIRA tickets a year in helping users get to data. And I can tell you that the range of users is huge, genuinely huge. And there are barriers for non-experts in using this complicated data. We don't always make it easy as a community. And I think coming from a legacy of meteorologists who knew what they were doing, we tend to then maybe tailor things towards that experience, and it makes it harder for new people to enter the marketplace. Usability of AI models. This one is a very new thing, evolving very fast. And it can be quite difficult for end users to utilize AI tools and models effectively. Again, coming back to the user support perspective, we spend a lot of time now telling people how to start an AI ML model. And these are people who don't necessarily have any background in this. They've just seen that it's something they want to try and they want to do, but we spend a lot of time helping them to do this. So we're not making it particularly easy, even if that would be a great goal. Trust and reliability, that is the whole concept of this session. It's the conference theme. There is a huge amount of skepticism among users of AI-generated forecasts, but this is not new because there's always been skepticism of weather forecasts in general, even from NWP. I know my mum does not trust anything that I do in my job. And then we have challenges in establishing credibility and trust with the general public, and again, I use my mum as an example. So in her view, the Met Office never gets it right. Sorry, Jeremy. So some of the things we can do in addressing these challenges, I've put on the right. This is by no means inclusive of everything. It's just some things that we've thought about and we've talked about. And that's developing tiered access. So I'll go through it in a minute, but making sure that users can get in at different levels. And this might be providing graphical products, linked to Jupyter notebooks that tell them how that product is made, linked to an API that lets them get the data and do it themselves, to processing it in a cloud environment. You've got to give different entry levels to different types of users. Intuitive user interfaces, that one goes without explanation. Regular user feedback. So again, in user support, one of the best things is hearing the feedback. How can we improve? How can we make things better? And then, as Umberto said in his first talk, listening and adapting and responding to what they say. That is a huge part of trust and collaboration, is listening and adapting and responding. Educational resources. Jupyter notebooks are a dream. I think they're brilliant. Effective communication. So making sure that you put out the information, transparency, effective, simple, understandable, reaching all levels. And then accessibility and usability tools. So I've already mentioned this, but a brief example of our tiered access. We have our open charts, free, public, CC by 4 license, very, very easy for everybody to use, and each chart has a description of what it shows and link to relevant documentation. For many of these, and it's really, really tiny, but there's actually a Jupyter Notebook symbol in the bottom. So many of these charts then link to a Jupyter Notebook where you can see how to retrieve the data, how we processed it, how we plotted it, and then you can tailor it. You can adjust it however you need. And then you can also download the data via an interface. So if you're not savvy with APIs, which a lot of our users are not, or you can use an API. And we also serve the data via a multitude of platforms, actually. So again, like the Met Office, we're very lucky to have partnered with Chris. And so we put our ECMWF open data into the AWS Open Environment Data Program. So that's about 1.7 terabytes per day. The data at the moment is the equivalent of NOAA, so it's at 0.25 degrees, 3 hourly, about 12 pressure levels of data, and it's under a CC by 4 license. That exact same data is available on ECMWF FTP, it's available on Azure, Google Cloud, and then this German, very nice German guy, is publishing it on OpenMeteo in point data format instead of gridded data format. And these are just the ones that I know of and that I liaise with, but I'm sure there are other copies or other people who are distributing this. But more importantly, these need to be well documented, they need to be well communicated, and they need to be maintained. And that's a really important part. Addressing data disjointedness. This is one of my favorite topics because I think, being really honest, and sorry, Umberto, but at ECMWF, we're not a shining example of well-connected data. We have differences in our own, in each of these factors, let's say. Even between ECMWF and Copernicus, we have big differences, and we need to harmonize, and there needs to be standard use, and this needs to be harmonized not just within ECMWF and Copernicus, but it needs to go a bit wider. So we need to go out to the masses, we need to make sure everybody is using the same approach so that data can be more usable, user-friendly. Nobody wants to have to go to 3 different APIs to download data from the same provider, which is what we're doing. And then this beautiful image, which is supposed to represent trust. And I come back to my original 3 questions. So thank you all of you who did answer the poll. There is still time, and I will still leave it. I'm planning to leave it for the rest of the week, so you can share it with your friends, share it with your colleagues, and then it'll form part of the summary that we have in the Google document. This is very new to me, but with some take-home messages that I will share as part of the outcome of this session. So again, these are the 3 questions. If you haven't done it, go for it. I'm going to reload the slider so you have like 2 seconds. Thank you for your time. How do I get out? So, how do I stop sharing stuff? Here we go. So the great news is we've been able to do, I haven't shared the screen. Okay, we have the Slido, and a great number of you, and we have some questions to answer as well, so we can go through those. Would you rather start with the poll or the questions? What's your preference? Okay, questions. Okay, let's do the questions then. So the first one, in regards to AIFS, how different is it in its strategies or objectives compared to similar AI weather models built by Google or NVIDIA? And I think I'll defer to Umberto for that one since he's leading it. Yeah?
I can expand on that because I asked that question.
Oh, you asked the question,
Yeah.
super, okay, go for it.
So I was interested when I saw in one of the slides about AIFS, and I just Googled it then and there. Because I've been a fan of Copernicus, now I get to learn they are 2 different entities. But anyways, what my question was, being from hydrology, I have 2 questions. One, the data sets that's available mostly from AI/ML models is dealing with atmospheric variables or maybe ocean variables. And we don't often see, as of yet, land surface variables being examined and how good that is. So it might be tangential, but the question is, why not? Or is there a plan to come up with or work with land surface variables? And the second one is, ECMWF has been a leader, but now with Google, NVIDIA, and others coming up, what is the role or the objective that ECMWF is planning to take? Because as you said, it's just not a group of folks, but these are scientists who are working and have knowledge about these. So is there a concentrated effort in learning something extra that these models, AI models, are telling us, instead of just an ensemble forecasts?
Okay, I'm trying very hard to, I'm going to defer to Umberto, but I'm trying very hard to find his face in this screen. But maybe Umberto, you can start speaking.
Yeah, I can start. Well, at ECMWF, we started using machine learning techniques a few years ago, and then more recently, clearly, together with the technical kind of organization, like you mentioned, Google and so on, we have been also accelerating, let's say, what we have been doing. So the first emphasis in creating AIFS was to have something that was producing, let's say, the same sort of variables so that people have been using for the training in other type of exercises. So these were typically atmospheric variable, as you said. There are parallel efforts at the moment, not yet published in that sense, at widening the scope of these things, including looking at the hydrology. But for us, the first priority was not just to have a data-driven model, as I said, in deterministic mode, but to have an ensemble version. So that is what we have released in terms of products fairly recently, and things will continue to evolve in that area. Once those are established, then the number of parameters will typically increase, including, of course, having more parameters on the surface of the Earth. So that is for the first, I think, part of the question. For the second part, I mean, I cannot really comment on what are the objective of Google and NVIDIA or other similar organization. From the point of view of ECMWF, I think our goal is still the same, to continue to improve the medium range weather forecast that we are doing, and we also go in longer range, and ideally to continue to have the best model performance for an operational system that we have. This may not be just as a purely data-driven model, like at the moment are these AIFS system. We are investigating also different areas, like what we call a hybrid version of our physical model using machine learning techniques as part of the model, or different, also even more different avenues where we would potentially just use observations to do forecast.
Okay. There are actually some slides I can share with you on these machine learning aspects, if that would be of interest afterwards. And there's one question that maybe I'll ask Jeremy, Simon, and Umberto to think about from somebody who says, can anyone talk about a time when trust was lost and how and whether that trust was regained? And I think that's an awesome question. Jeremy has an answer, and I think Simon's ready as well. So Simon, do you want to go first, and then?
Oh, wow. Gosh.
Oh, yeah.
I was, Jeremy, you've picked the same one. You go for it. You're in the room.
Okay, so back in the UK, there was this weather system that was coming in from France, and we had a very famous weather forecaster called Michael Fish. He said, I've been hearing people thinking there's weather coming. He said, nah, don't need to worry about that. It's not coming. It was the most severe hurricane that struck the UK in decades. It caused widespread damage, and there was some reputational loss. But the interesting thing is that if you understand how you failed, what you didn't do, and then say, please help us address those. So basically fess up, honestly appreciate what you could have done better. that storm enabled the Met Office to draw down more funding and improve its forecasting, so we didn't do it again. But the important point was that we admitted the mistake and used that as the baseline to improve. That's my opinion. I don't know if you have other thoughts.
No, I think that's accurate. And I think one thing that ECMWF does is we review forecast busts. When we make a mistake, we have a look at the forecast bust and we look at where it went wrong, why it went wrong. And we have a list of our known weaknesses. We don't hide them. We have all of our flaws published publicly on the website. So if you want to look for areas where we know we're not particularly strong, and I think this is something that's quite important, is not hiding your flaws. We have a question from Dave.
It's more like just a quick comment. Dave Jones with Storm Center Communications related to a failure resulting in an increased funding. That's kind of how it works here in the U.S. is that, when you have a landfalling hurricane that has major impacts, it seems like Congress allocates supplemental funding to improve forecasting, improve the research of social science, improve all these things. And it seems to happen year after year. So it's, Sandy was tropical storm, Hurricane Sandy was 2012, was a real big, resulted in a real big funding bump for here in the U.S. Weather Service, NOAA.
So I think we've actually reached the end of our allocated time slot, and I don't want to delay the drinks reception. I'm also freezing, I'm afraid. So I would ask you all, if you don't mind, there is a Google collaboration document. It would be really useful for us in the name of collaboration to know who you were and where you come from. So if you could add your name to the attendance list. And keep an eye on the document, because I'll add some of the Slido results, some of the other questions, and any feedback that we get that may be useful to everybody. And I thank you all for your time. It is nice to have met you. Thank you.